and our first speaker is Markus Legner, who is actually by training a theoretical physicist. I found this amazing to see in your CV that you have a PhD in theoretical physics and only then decided to go into the network security area, where you then worked on next generation internet, and also then now you are with, I hope I pronounce it properly, Mysten labs, where you try to combine, and that will also be the topic of your talk, next generation internet and modern blockchain topics, and that's what we'll learn about. The stage is yours.
Yeah, thank you very much. Thank you for the kind introduction. Thanks for the invitation. It's great to be in Garching today. As Sebastian mentioned, I spent several years as a postdoc at ETH Zurich, where I worked on a next generation internet architecture called SCION, as a postdoc in Adrian Perrick's network security group. Funnily, this is not mentioned on my CV, but I actually worked for Siemens for some time. But then last year I joined the research team at Mysten Labs, coming back to the next generation internet architectures and to apply those in the real world. Today I want to talk about some of the synergies between SUI, the blockchain that is being developed at Mysten Labs as a representative of modern blockchains, and the next generation internet architecture, SCION. Just a very brief history about of Mysten Labs and SUI. I don't want to do an advertisement talk. Mysten Labs is a young startup, but already quite successful. It was founded in 2021. And in May of last year, the mainnet of SUI was launched. This is a new high-performance layer 1 blockchain. It has already reached some major milestones since. For example, it recorded the most transactions on a single day by any blockchain last year. And this year we celebrated 1 year of mainnet with zero downtime. Now, Mysten Labs is working on further improving the consensus infrastructure at the heart of the blockchain, but also is working on completely new ways to use the blockchain. An important element of these efforts is SCION, where Mysten Labs has made substantial investments and wants to use this technology to within its production deployments in the coming years. So, in this presentation, I focus on a system that all blockchains fundamentally depend on, but that is sometimes a bit outside of the spotlight, and that's the networking layer. And first, I want to discuss why we are even talking about this, why we're even exploring new technologies in that realm. Put simply, the decentralized nature of blockchains brings some very peculiar challenges concerning networking. As you all know, to prevent any single entity or even single countries from interfering, blockchain nodes are ideally globally distributed, and generally a threshold of them needs to be reachable and online at all times to prevent attacks in proof-of-work blockchains, for example, or to completely halt the consensus. This means that fundamentally, blockchains rely on an available and reliable global networking infrastructure. Especially if we want to achieve all the promises of Web3, supporting real-time applications for hundreds of millions or even billions of people, any disruption on the networking layer that disrupts the blockchain operation could be catastrophic. Unfortunately, the internet that most blockchains rely on today is far from secure. I'm sure all of you have heard countless reports about hacks, malware, phishing, ransomware, and so on. However, when I talk about the internet today, I'm not talking about websites and these kinds of things, but really the network infrastructure and protocols that are used to exchange data between hosts. While this part is not quite as visible or not featured in the news as much, the very foundations of today's internet can be attacked and even render other security protocols like TLS ineffective. Specifically, malicious actors can reroute traffic towards their own infrastructure and thus either disrupt communication or impersonate the intended communication partners to each other. There are several examples of such attacks, also some in the space of cryptocurrencies. There was an attack on my Ether wallet in 2018 and another attack on ClaySwap in 2022. Overall, tens of millions of dollars were lost in these attacks. Now, unfortunately, and now I'm coming back to the peculiar challenges of blockchains, blockchains cannot rely on the same solutions to achieve security that other globally distributed systems use. Such systems, for example, content distribution networks, often operate their own private network. They buy leased lines and thus achieve security control and isolation. But this is not feasible for blockchains because those promise that there is no single point of failure. If we now have a single networking provider that is trusted with exchanging information and that provider goes down or is attacked, then this could disrupt the blockchain operation again, and we would have this single point of failure. I'm not aware of any blockchain that has a comprehensive set of defense mechanisms against these kinds of attacks, but what we would really need is a decentralized, public, redundant network that is guaranteed to be available and reliable. A bit more concretely, we have several types of communication that need highly available network communication. One is the internal communication between validators, and the other one is the communication between clients and blockchain nodes. In the first case, we want to ensure that even a very dedicated attacker, a very powerful attacker, cannot disrupt the consensus protocol that is run between validators. And in the second, we want to guarantee that clients that want to use the blockchain can actually reach the blockchain at all times and execute transactions without delay. Of course, we do have, like other blockchains, lots of existing protection for the systems, like any other critical IT system. All messages are cryptographically authenticated. We have multiple layers of filtering and rate limiting to defend against denial of service attacks and so on. But still, the situation is less than optimal. Ideally, we would prevent many of these attacks directly at the networking layer. And the networking layer itself would provide us with availability guarantees. So we're looking at networking solutions that provide this built-in security and resilience against attacks. And as mentioned before, this should not introduce any new single points of failure. Luckily, there happens to be such a technology already. It's called SCION, and it has been conceived 1.5 decades ago by the Swiss computer scientist Adrian Perrick and has been developed ever since by many researchers across the globe. SCION is an internet architecture, which means that it coordinates multiple smaller networks, just like today's internet. Remember, this fact is crucially important for blockchains because we do not want to rely on single entities. However, in contrast to today's internet, we do have a secure routing protocol. So the routing protocol is, the function of the routing protocol is to find paths between end hosts. And this routing protocol that replaces the BGP protocol in today's internet leverages cryptography to ensure that it cannot be influenced and attacked by unauthorized parties. But not just routing is changed. A new packet forwarding protocol that replaces IP, the internet protocol, provides much more control for end hosts. Instead of just providing a source and destination address, a SCION host can actually select among multiple paths that exist between itself and the intended destination and encode this choice in the packet header. This also provides some defense against rerouting, but it can also improve latency. For example, you can choose to send a packet eastward from Europe to Southeast Asia instead of going westward via the United States, which often happens in today's internet. It also allows the sender to exclude certain networks it distrusts or route around failures in the network. This is not just an academic system. SCION has been in production use since 2017 and has been analyzed widely and is now actually used by several critical infrastructures in Switzerland, including finance, healthcare, and energy. Now, this originally grew out from Switzerland, so the biggest deployment of SCION is actually within Switzerland. But of course, SUI has validators globally. So together with its partners, Intercloud, Cyberlink, and Anapaya, Mysten Labs has built 2 global SCION rings to provide a redundant SCION network between important points across the globe, and actually provide triple redundancy if you count the current internet as well. For the deployment at validators, we actually leverage an appliance created by our partner Anapaya called Edge, which can be deployed as a virtual machine on existing bare metal hosts. This appliance contains all the SCION components and acts as a gateway to encapsulate traditional IP packets into SCION packets if the host is reachable through SCION. This has the advantage that our validator code does not necessarily have to be changed. The validator can still send out IP packets, but it would then be encapsulated through this gateway, and that takes care of sending packets on the best paths that are available. Of course, not all the validators might be reachable through SCION, so there's actually a redundancy between the SCION and the IP internet. So there's a routing daemon that shares which hosts are reachable through SCION with the validator host, so that the validator hosts either sends out the packets to the internet or to SCION. And as long as either SCION or the internet is available, the validator would remain connected. A detail just to make all of this very efficient, we use hardware-based virtualization to share the network interface card between the host and the guest VM. We now have actually several of these instances running, and we will expand the deployment of this setup to further validators, first on the SUI testnet and then later on the SUI mainnet in the coming months. In a bit more long-term future, we're also thinking about integrating this a bit more tightly. So we have implemented the SCION networking stack in Rust to be able to integrate this into the validator code in the future. Now, for the last part of my presentation, I want to look at blockchains and future internet architectures from a different angle and explore whether and how the SCION architecture can in turn profit from blockchains. And to understand the possibilities, I want to explain why my title explicitly mentioned modern blockchains. Specifically, I want to stress that modern blockchains have properties that are sometimes orders of magnitude better than the initial blockchains like Bitcoin or even Ethereum. And only these vast improvements make it even conceivable to use a blockchain for networking protocols and network providers. So I don't want to go into too much detail here. I'm sure you're all familiar with this, and I don't want to go too much into advertising. But I want to emphasize that we're really orders of magnitude more efficient, more performant, and more economical. For example, you can process thousands of transactions a second, and you can pay less than a cent for these. And you're sure within less than a second or a few seconds that your transaction succeeded. Now, these improvements really make it possible to build completely new decentralized applications, also in the context of networking. This brings us back to SCION, which in turn is uniquely suitable to benefit from this system because it has a clean separation of control and data plane. What I mean by this is that, as I mentioned briefly, a SCION packet carries in its header some encoded path from the source to the destination. So the router in the network does not actually need to make complex decisions. The router just needs to look at the header, check if this is authentic in some way, and then follow the instructions within the header. And it does not need to care or know how this information was distributed initially. So instead of an in-band routing protocol, certain tasks could be performed by an external system like a blockchain. A blockchain, in turn, is ideally suited to play this role because the decentralized nature of the blockchain matches perfectly the decentralized nature of the internet. And neither of them relies on single entities or single roots of trust. So what can a blockchain-based system do in this context? Well, a blockchain, especially if you have an object-centric smart contract language like Move, which is used in SUI, provides all the mechanisms necessary to create digital assets for networking resources. These assets can be composed, transferred, and coordinated through the use of smart contracts, and that can happen between multiple parties without requiring dedicated and complex multi-party protocols, because the blockchain serves as the consensus layer. A particularly useful feature is that multiple operations can be made atomic, so that either all of them succeed or all of them fail. In addition, financial settlement can be integrated so that it's financially interesting for network providers to participate in these systems. Of course, many control plane mechanisms in networks, like finding paths, distributing information, need to be very fast, and they need to be very cheap because they happen all the time. So we really rely on these properties of modern blockchains for that. As a concrete example of such a system, in our team we have designed a quality of service system for SCION, where the SUI blockchain is used as a control plane to create bandwidth reservations, so a reservation to use a certain amount of bandwidth on a specific path through the network, and distribute this to end hosts. Other possibilities we're exploring is distributing keys or other forwarding information. Now, a main challenge, of course, for all of these things is the question of how to tie the on-chain assets to the physical resources like network bandwidth. Specifically, only a legitimate network operator should be able to create bandwidth assets, and only the holder of such an asset should be able to claim it. So in our system, we achieve this by actually providing encrypted authenticators to the holders of assets in a separate redemption step that they can then use to authenticate their packets. If you want to know more details, please take a look at the paper mentioned in the footnote or approach me later. Now I'm coming to the end of my presentation and just want to say a few words about our current efforts and next steps. Essentially, we're focusing on 4 topics. Our primary goal is really to protect the SUI network with SCION connectivity, first the testnet and then the mainnet. This will also require onboarding more global carriers to expand the reach of the network and working with validators and full nodes to get them connected. This will keep us busy over the next months. The other projects are a bit more long-term oriented, so we're looking into additional defense mechanisms that are available in the SCION network to integrate them in our setup and provide even higher security levels. And finally, this comes to the last part I just discussed before. We're exploring ways to leverage the SUI blockchain for applications in the area of networking, specifically related to SCION. Before I conclude, just a hint that may be relevant for some, like the Web3 Foundation, also the SUI Foundation has a grants program for research related to blockchain called Academic Research Awards. You can find it on the internet. I don't have a nice QR code. But with that, I want to conclude. I'm looking forward to your questions, and please also approach me later today or tomorrow, or reach out via email. Thank you.
Thank you, Markus. We would have time for a question. Anyone dares? Georg.
So, thanks for the talk, and me being also having a network background, I have a lot of sympathies of strengthening the network, and so SCION, of course, is an interesting approach. Now, what is your observation what other blockchains are doing at the network area, and would you say, or would you expect changes in the larger community?
So I'm a bit more knowledgeable about networking than about blockchains, I have to confess. But I think the things that blockchains generally do is these kind of classical things that I also mentioned. Like we have authentication, we have filtering, we have rate limiting. There are some other ideas that you distribute your validators in certain ways that make the communication a bit more secure, but that always carries the danger of too much centralization. So I really think the best way to go is a distributed network. Of course, SCION is a relatively new technology, so this has to grow and will provide all its benefits in the long run. I expect that if this is widely available, that other blockchains would probably use it as well. But yeah.
Okay, there's another question.
A small remark. Compared to the age of typical blockchain technologies, SCION is a very mature technology.
Yeah, that's true, and well tested. Yes.
I was wondering, so what's the penetration of SCION? Like you said, you have fallbacks also for nodes that don't have it, if I understand correctly.
Sorry, can you repeat this? I didn't.
So I understood that you also have fallbacks for nodes that don't have SCION connections right now. So do you have any data on how many nodes have SCION, of how many total validators you have? Like what's the percentage?
So okay, so currently we're still in the kind of ramp-up phase, where the way the SCION network is built, we will reach a bit more than 2/3 of the validators, which is sufficient to reach quorum, which is nice. The good thing is that really we do have this redundancy. We don't want to rely purely on SCION, so we actually have the best combination, right? As long as either SCION or the internet work, we can communicate, and we don't need to necessarily be able to communicate with all other validators, just a few of them, which can then communicate further. There could be even the case that the SCION validators can communicate with each other through SCION, and then there are some of them that also still have IP connectivity and can reach some of the others. So this really is a relatively, it's a very secure setup, where even if you now think that SCION might also fail, we still have the IP internet.
Okay, thanks a lot to Markus.
One more.
There was one more question. Quick question we can accommodate.
Yeah, very quick question. Just for basic understanding, I guess. Is SCION like a level 3 protocol running besides IP, or is it like its very own thing running bare metal on its own infrastructure?
Yeah, so good question. I could provide a very long answer, but the idea of SCION is that it reuses most of the networking infrastructure and just touches the points where autonomous systems communicate with each other. So the edges, the edge routers, the border routers, which makes it much more easy to deploy because you don't need to replace all your infrastructure. You only need to upgrade on these borders. It is a layer 3 protocol, so it runs side by side with IP, and it can reuse the same infrastructure. Now, of course, you need to be careful there to make sure that they still are isolated so that an attack on the IP internet does not touch the SCION internet, but this is usually what the network providers do that deploy SCION.